How do you find velocity from a position versus time graph? Velocity is found by the slope of a line, and velocity includes both speed and direction, right? And so it can be positive or negative, because positive and negative is just a direction. If it's going forward, positive. If it's going backwards, negative. So velocity is equal to the slope of the line. In slope, if you remember from your math days, was just the rise over the run. How much did the line go up divided by how much did it go across? Now, why does it equal slope? We're doing a whole another video on that, so you can check that out in the link. But let's jump into finding the velocity from this position time graph. So at 2 seconds, you just go here, and this time you're looking at what part of the line it's on. Okay, and you see it's on this line right here. And so you're going to find the slope of this line. Wherever that dot lands on, look at, there should be a straight line, and wherever that straight line is, that's where you're going to find the slope. And the velocity is going to be the same anywhere on this straight line. So whether we find it at 1 second or 2 seconds or even 2.3 seconds, it's going to be the same velocity, and it's going to be equal to the slope of this line. Okay, so you notice this line has a rise of 6 because it starts at 6 and goes up to 12. Has a run of 3 because it changes into a flat line here at 3 seconds. In between, it looks like it's about 3 seconds. We're going to say 3 seconds. Rise over run will tell you our slope. So 6 over 3 is equal to 2. And what that means is the velocity of this object was 2 between 0 and 3 seconds. So how fast was it going at 1 second? It was going 2 meters per second. At 2 seconds, it was going 2 meters per second. At 2.179 whatever, it's going 2 meters per second. It's going to go 2 meters per second until it gets here, and then it changes velocity. So some people would like to put this on a velocity time graph, and the way you do that is, you notice this lasted for 3 seconds, and it was a velocity of 2. You just have a flat line here. Now let's look at, any time the slope changes, we have to find a new slope. So let's look at 4 seconds, which is on this flat line. And the slope here is just 0 over 3, because rise is 0 for a flat line. And 0 over 3 is 0, which means the velocity was 0. Okay, and as we said earlier, he's not moving at this point, so that makes sense. So the velocity will be 0 until it changes right here at 6 seconds. Okay, so that's why you have a 0 velocity here. Now for the third part of this position time graph, it's sloping downward. Downward does mean we're going to see a negative velocity, okay, because it's moving in the negative direction, and so we call that a negative velocity. The rise is negative 12. So when we look vertically, if it from left to right it goes down, we assign a negative number to the rise. Its run is 4. It goes from 6 seconds to 10 seconds. Rise over run, minus 12 divided by 4 will be a velocity of minus 3. Okay, so we have a velocity of minus 3 for the final 4 seconds, and that's our velocity time graph. And so you can see here we're able to find the velocity anywhere on the position versus time graph. While it's going forward, we had a positive velocity. While it was flat, we had a 0 velocity. While it was going down, we had a negative velocity. Right? And so and we're able to find out what those numbers were by finding the velocity, by finding the slope of this line. And we're able to find out what these numbers were by finding the slope of this line. All right, so that's how you can find the velocity from a position versus time graph. Hope this video helped you all, and we'll see you in another video.